Okay, so I wanted to take a few minutes to go through how we use law of sines to solve trigonometry problems. So let's take a look at one example. This is actually example 6 from the 8.4 practice problems that we're going to look at. So here's the problem. Now, what happened? I forgot the law of sines. Well, remember we derived it in class, and so if you don't remember it, you can derive it. How did we derive it? We actually dropped an altitude. So here's my altitude k. So when you pick this vertice, label the vertices. So vertex B, I'm just going to drop a perpendicular from that, which creates this right angle here. Remember, perpendicular lines form right angles. So this gives me the altitude of the triangle. Now, I can use SOHCAHTOA because I have a right triangle. Now, SOHCAHTOA only works for right triangle trig, so this is what I'm going to set up. Now, I know one angle and one side, and I'm looking for this side. So what is that? If I'm standing at 27 degrees, I'm standing at this angle A, this side is opposite. The longest side, of course, is the hypotenuse, and then this would be the adjacent side here. So if I know that I'm looking for the opposite side, and I know the hypotenuse, it's going to be a sine problem. So sine of 27 degrees equals k divided by 25. I can rewrite that by multiplying both sides by 25. So k equals 25 sine 27. And you can just plug that straight into your calculator, just as it is, as long as it's in degree mode, you'll be fine. I think I'm losing my voice, so I apologize. K is approximately equal to 11.35. So now we need to find x. So to do that, I can set up another problem where it's sine of 50 degrees. I now know what k is over x. So I've rewritten this equation. K equals x times sine of 50. What I could do is just substitute in 25 sine of 27 degrees for k. And then, if I divide both sides by 50, sorry, my recording stopped for a second, so I'm not sure where I left off. So, k equals x times sine of 50. And I could just substitute that in, divide both sides by 50, sine of 50 degrees. That gets x by itself. And there I have that. I can plug that right into my calculator. 25 times sine of 27 degrees divided by sine of 50 degrees approximately equals 14.8. Now I know this is a lot of steps. So a simpler approach is actually to use the law of sines. Now you can use the law of sines if you know two angles and a side of a triangle, you can use law of sines. And the reason you can do that is, let's take a look. So if I know two angles and a side, I have these two angles here and maybe one side, I can find the other side. All right? So this is how law of sines works. Remember, if we're, say, at angle A, if I'm standing here, staring across from me is this side length. And the measure of that side length is little a. Or if I'm standing here at angle measure C, staring opposite me is this side length here, which is length of C. And then the same here for B. Now I know variables sometimes throw us off, so let's look at this problem in 6 because it has some numbers attached to it. So, if I'm standing at this angle, which has a measure of 50 degrees, this side opposite me has a length of 25. That is what I'm going to use in my law of sines problem. And then the other one is 27 degrees. Opposite that is what I'm looking for. That's the unknown. So I can set up my law of sines problem just like this. 25 divided by sine of 50 degrees equals x divided by sine of 27 degrees. Now this is a very useful thing. We can then multiply both sides by sine of 27 degrees. And that gives us this, rewritten. Hold on a second. Let's go back. right here. Look, that's exactly what we had written here. This is what we derived using right triangles. So it's the exact same problem, just with a fewer steps. So we can then plug that into our calculator, and I'm going to show you exactly what you need to type in your calculator. So you would type 25 times sine, and remember that's going to create an open parentheses, 27, close the parentheses, divided by sine again, which creates an open parentheses, 50 degrees, close the parentheses, enter. That should give you approximately 14.8. It's like 14.81606269. Now, the problem asks you to round it to the nearest tenth, so it's 14.8. So I hope this helps. Please let me know if you have questions.